So we have a few frames here, and I think this is looking pretty good. I don't think we really need to add more turbulence to this, but what I do want to add is a little bit of breaking of the smoke when the particles have a high velocity. So let's go back and simulate a few frames here in the start. Let's maybe just go up a level, and for this .NET I will increase the, let's go to cache and just give this a little bit more memory. And let's go back up. So I want to simulate a few frames, and right here when the pieces have the highest velocity, I want to break this up a little bit so we can use that speed field that we created and map it to a disturbance microsolver. So this should be fine. Let's go ahead and add a gas disturbance, gas disturb, and plug this into our forces. And let's set this to be block based. Let's leave the strength at 25, and maybe if we go to the control field, we will set this to our speed field. And let's go to visualization and let's turn this on. And we can see that this is way too high, so maybe go to the settings, set this to a value of 10. So still too high, I think, maybe 5. Let's go to the control and maybe give this a little bit more range. So let's use a value of 2. So if we simulate, let's see what we get. And maybe let's cut the disturbance entirely until you get a speed of maybe 0.5. Alright, so now we are focusing the disturbance only on the parts that are reaching a certain speed of 0.5, and maybe use 1.5 here for the max speed. Maybe let's go back to the settings. I'll leave the strength as it is. Let's turn off the visualization for now and see what we get. So we have some disturbance, but this is probably a little too small of a value, so let's go to the settings and set this to 10. Alright, so I think this should be fine, and we already see that we are getting a lot of detail in our simulation. And I forgot to set one thing for my velocity source. We can turn this enlarge fields to contain sources off to save a little bit of computational power. And these settings should be fine. So let's go ahead now and see how we can take care of the collisions. So for both the smoke simulation and our pop simulation, we will use the same collision source, which will be a volume collision. Let's go up. And again, for the collision, to optimize things a little bit, we will only need the pieces that are moving. So just the same way that we created a separate source for the debris pieces, we will want to, let's maybe grab all of these, copy these over, and create a separate chain over here for the collision. And we can get rid of all of these extra nodes, and we just want to work with the pieces. So we just have our main fractured pieces, and these are the ones that we are interested in. So from here I will drop this into a, let's maybe get rid of this null, and let's drop a VDB from polygons. So from here I want to maybe just decrease the voxel size and give this a little bit more resolution. And we will create a distance VDB and rename this to collision. So this is the name that is recognized inside the pyrosim. And we will also need a vector field that contains our velocities. So let's also include a surface attribute. And maybe while I set this up, I will turn this to manual. And the attribute will have to be point V. So just select from the drop-down list point V. And the VDB name, again, this is specific for pyro, so I will rename this to collision vel. And for vector type, this has to be a displacement velocity acceleration vector type. And I will set this to auto update. And we should have our fields now. So here we have collision and collision vel. And I can go ahead and save this, so drop down a file cache. And if I preview the retime points, we can see that we should stop at around frame 140, I believe. So we can go to our file cache, and this should be up until 140. So right until the very last piece settles, and then we can simply use a time shift and freeze the frame at 140. Let's disable version and select the folder, and I will rename this to collision. And before we save to disk, let's remember that we set our simulation for the smoke. We are using 2 substeps. So let's go back here and make sure that we are caching the substeps as well. So here for the file cache, I will increase the substeps to 2. And now I can save to disk. And now that we have this cached, we can see this is how it looks. And we can just drop down a time shift here, and like we mentioned earlier, let's disable integer frames, so we will want to use the substeps as well, and just use a clamp to last, which I will set to 140, just so we hold this at 140 where the cache ends. So we ensure that the collisions will pertain throughout the whole duration. So from here I can drop this into a null, and we can say that this will be our pyro collision. Let's grab this node, Control C, and let's bring this over inside our .NET. And let's go to the first frame. And this has a little weird setup with the Pyro Solver sparse version. We will have to import this collision as a volume source. So I will type here volume source. And let's place our subpath to point to our collision, and we want to, let's maybe go to the initialize, and there is a preset for collision here. So let's just click this, and in here we can see that this is looking for a scalar field, which is the collision, and the collision val for the velocity. So these are the names that we gave our fields when we created the VDV from polygons, and you can see that these are the names that are recognized by this preset. And this volume source, let's maybe rename this to collision. This has to be plugged inside our forces input. So we can merge these two together and plug this into the forces. And for debugging, let's go to our smoke object and let's turn on collision and see that this works. So let's just play the animation. And we can see that we are sourcing in the collision volume as well. So we can safely say that this is working. And we can turn this off. So let's go up a level and let's import our smoke to the subfield. So drop down a DOP import fields. Let's point to our .NET, and I want any object that has smoke in it, which will be our smoke object, and fields will be density, and we don't really need to import anything else. So let's see that this works, and it does, and we can now cache this entire simulation. So drop down a file cache from here and simulate the entire animation, so up until frame 200, disable version, select the folder, and I'll rename this to smoke and save to disk. So this will be our smoke simulation, and let's preview the animation, and let's preview this from the camera. So unfortunately I think the dissipation is a little bit too strong, and I want the smoke to last a little bit longer. Let's maybe go ahead inside this .NET, and I will disable the dissipation entirely. So let's go to the Pyro Solver and maybe just get rid of this dissipation, and I will go ahead and recache this now. So now our smoke should last throughout the whole animation. And what we can do later is, the way that we are going to set up the layers inside of Nuke is, this smoke will be a separate render that we add on top of our ground, and we can simply fade it inside of Nuke directly if needed. So we will have more control over the smoke simulation if we just cache the entire animation with no dissipation. So now our smoke should be lasting throughout the whole animation. Alright, so this is fine, and let's drop down a null here, and this will be, let's say, RNDR smoke. And now we can move forward for our particle simulation. So this part over here will be our smoke, and I will press Shift O, and I'll just give this a title here. So smoke This is my debris source. Okay, and over here we can create our chain for the particles. And let's first maybe encapsulate these as well. So this is, let's see, let's grab one of these, and this is the debris pieces. And this is, let's shift O. This can be VDB collision.